Topic 2 in triple science. So the first thing is nanoparticles. A nanoparticle is between 1 to 100 nanometers long, and they have large surface area to volume ratios. Nanoparticles can be used for catalysts because of that large surface area to volume ratio. They can be used in drug delivery. So for example, medicines can be put inside the nanoparticle, and then this can be carried to different parts of the body. Also, because they conduct electricity, they can be used in computer electronics. And here are some other examples of uses of nanoparticles. Now, the public, for example, in cosmetics, don't approve the use of new technologies such as nanoparticles because they don't know the long-term effects of it. So at the moment, it might look like it's having a good effect. However, we don't know what effect this will have on humans in 10 to 15 years' time if they start using it now. Now, continuing. With gases, so there's two formulas. One, number of moles is equal to volume over 24, or number of moles is volume over 24,000. Now, the only difference between these two is what units the volume is given to you in. So if the volume is in centimeters cubed, you use this formula. If it's given to you in decimeters cubed, you use the top formula. Again, you can always convert between them. So for example, you know that 1 decimeters cubed is equal to 1,000 centimeters cubed. So if you have decimeters cubed, times it by 1,000, that will give you centimeters cubed. Okay, so find the volume of gases in the following. So you have 0.25 moles of methane. So again, the formula we're going to say is number of moles equals volume over 24. So here I'm going to use volume as decimeters cubed. So I know it's 0.25 times by 24, and that should give you, so that's a quarter of 24, so that's 6 decimeters cubed. So that's how much volume you have. What about if you have 0.22 grams of carbon dioxide? So first here we have to first turn that into moles, and then we can turn that into volume. So we know the formula, number of moles is equal to mass over molar mass. So we know that number of moles is equal to mass over mR. So if you have 0.22 grams of carbon dioxide, then you can turn that into moles by doing 0.22 divided by mR of carbon dioxide, which is 44. So once you've done that, now you have moles, and then you can use the first equation to convert that into gas. So what you'll do is you'll do 0.22 divided by 44, and then times that by 24. So then what you get is, so once you've done that, times that by 24, and that will give you 0.12 decimeters cubed. If you wanted the answer in centimeters cubed, you would have times it by 24,000. Okay, so find the number of moles of the following gases. So you here, again, our formula is number of moles. Number of moles is equal to volume over 24, or volume over 24,000 if the volume is in centimeters cubed. So for the first one, we have 48 decimeters cubed. So you're going to do 48 divided by 24. That will give you the number of moles. So that should be 2 moles. In the second one, you're going to do 360. Now, because it's in centimeters cubed, you're going to divide it by 24,000. So that will give you 0.015 moles. Okay, atom economy. Now, atom economy, there's an important formula that you need to know. Mass of desired product over mass of all products. So for example, if you have this reaction over here and you want to find out what the atom economy is, so it says calculate the atom economy to form aluminium, which means that aluminium is your desired product. So what you're going to do is, you first of all, what's your desired? So you've got 4 times by Al over 4 times by Al plus you've also got 3 times 2, so you've got 6 lots of oxygen. So that's going to be 4 times 27 over 4 times 27 plus 6 times 16. And then you can, if you want to turn that into a percentage, you just times it by 100. Otherwise, you can also leave it as a decimal. Ignore this. This should say atom economy, not percentage yield. Okay, so why is it good to have high atom economy? So here are some reasons. So you have less waste products, you use fewer resources, it's profitable as well for you. So make sure you memorize these points, because it could be an easy 1 or 2 marker. Now, in a titration, you have an alkali reacting with an acid. Now, this thing over here is called a burette. This is called a conical flask. Now, notice the conical flask, the edges become narrow, and the reason we use this is because when we swirl, we don't want the liquid to pour outside. So if we have this narrow edge, narrow neck, that means the liquid will stay inside. Okay, now over here you have the method, and here you have ways that you can improve it. So if they ask you to explain how you do titration, you go for this side. If they ask you how you could improve your titration, you talk about these stuff. Now, with titrations, you always want to use an indicator. So indicators tell you exactly when all the acid or all the alkali has finished reacting. The three main indicators you need to know about are methyl orange, litmus, and phenolphthalein. Don't get this confused with litmus paper. That's something else. So this is just litmus, the indicator. It's the solution. So methyl orange, in acidic it's red, but in alkali it's yellow. Litmus, in acidic again it's red, in alkali it's blue. And phenolphthalein, in acidic it's colorless, but in alkali it's pink. You do not use universal indicator for titrations, because what you want is a sharp change in color. If you use universal indicator, there'll be a gradual change and you won't know exactly when all the acid or all the alkali has finished. So you want to use an indicator that only has two colors, so you know exactly when the titration has finished. Okay, so a titration calculation, we're going to use the formula for concentrations, which we did earlier. Number of moles equals concentration times volume divided by 1,000. So looking at this question, first of all, what you want to do is pick out what exactly they're talking about. So it says here, sodium hydroxide reacted with ethanoic acid. So those are the two main things they want you to talk about. This is ethanoic acid, and that is sodium hydroxide. So what you want to do is write them out, make sure the reaction is balanced before you proceed. Then what you do is the following. You write NCV, NCV, which stands for moles, concentration, and volume. Then going back to your question, you want to read whatever they tell you and fill up your table. So for example, you have 25 centimeter cubed of sodium hydroxide. So you're going to write that over here, 25 centimeters cubed. Then that and also it has a concentration of 0.15 molar. So 0.15 moles per decimeter cubed. Now, what else do you know? We also know that we have 30.3 centimeters cubed of ethanoic acid. So that's 30.3 centimeters cubed. And what do they want us to find? They want us to find the concentration of ethanoic acid. So I'm going to put a cross here. Now you can see exactly what you have and what you need to get to. Now the rule is that to find something, you need to know the other two. So for example, if I want to find concentration, I need to know moles and volume. If I want to find volume, I need to know concentration and moles. So for here, to find concentration, I need to know volume and moles. I already know volume, but I don't know moles. However, is there moles of something else I can work out? Yes. I can work out the moles of sodium hydroxide, and I'll use the formula N equals C times V divided by 1,000. So we did this in topic 3. So it's going to be number of moles for sodium hydroxide is going to be 0.15 times by volume, which is 25, and then you're going to divide that by 1,000. So that will give you 0.00375 moles. Now, the ratio of sodium hydroxide to ethanoic acid is 1:1, which means the moles are the same over here, 0.00375. Finally, to convert that into concentration, we have to rearrange this formula. We want to find concentration, so bring the 1,000 up. So you're going to get 1,000 times by moles divided by volume is equal to concentration. So you're going to do 1,000 times moles and divide that by 30.3, because this time we're looking for sodium hydroxide. So it's going to be 0.00375 times that by 30.3, times that by 1,000, and then divided by 30.3. And the answer should be 0.123 moles per dm cubed. It says give your answer to 3 significant figures, so that's going to be 0.124 moles per decimeter cubed. Okay, so in this question, same principle, but just be careful because over here the ratio is 2 to 1. So that means if you know the moles of hydrochloric acid, to go to barium hydroxide, you have to divide by 2. And if you know the moles of barium hydroxide, to go to hydrochloric acid, you have to times it by 2. Okay, moving on to topic 5. Now, this is an electrochemical cell. What you have is a pair of electrodes which are both made of different metals, and the key word here is different. If you use the same metal, this won't work. So you have to have 2 electrodes. You have a liquid that they're dissolved in, which has not dissolved in, they're placed in, but this liquid has dissolved ions. So this is called an electrolyte, and of course a voltmeter, which will tell you how much voltage is created. This does not have to be here for it to work, but it's good to have it so you can see exactly how much electricity is being made. So the way it works, okay, they might ask you in an exam, explain what can affect the value of the voltage. So the first thing is the type of electrodes used. So the electrodes affect V. The electrolyte used also affects the voltage, and finally the temperature of the reaction affects the voltage. Also, you can say the difference in reactivity affects the voltage. Okay, now over here you can see that this cell has a voltage of 2, this one is 2.5, and this is 1.5. So in total, if you connect them all like this in series, their voltages will add up. So this will give you a total of 6 volts. Okay, now looking at this question, you might get electrode questions which will ask you to work out the electrode potential of a cell. So what you're going to do is read the question and make sure you understand exactly what it's saying, because most of the information is already in the question. So for example, 2 voltages of 2 simple cells made with the same electrolyte and different electrodes are shown. Now, if the metal used for electrode A is less reactive than the electrode B, the voltage is positive. So you're going to make a note of that. So if A is less reactive than B, that means you're going to get a positive voltage, a positive answer. And if A, therefore, is more reactive than B, that means you should get a negative answer. Okay. Now it says, calculate the voltage of a cell where electrode A is lead and electrode B is tin. Okay, so right now we can see that when the electrode A is zinc and electrode B is lead, this is one cell, and another cell is zinc and tin. So when electrode A is zinc and electrode B is lead, the voltage is negative. So the fact that it's negative, that means that A is more reactive than B. So we just worked out that zinc is more reactive than lead, because when A is zinc and B is lead, the answer is negative. So A is more reactive than, and we know that from the questions. Okay, so we can just quickly write down that here zinc is more reactive than lead. So zinc's above lead. Now with the zinc and tin, again you see a negative answer. So again that means zinc is also more reactive than tin. So again zinc is more reactive than tin. Okay, now we want to compare lead and tin. Now out of these two, out of lead and tin, who's more reactive? Well, we can see that when you have lead and zinc, the difference is 0.5, but when you have zinc and tin, the difference is 0.35. So there's a smaller difference between these two. Because there's a smaller difference, that means that there's the reactivity difference is less. So the answer is 0.35. So therefore tin is closer to zinc than lead is. So tin is actually a bit more reactive than lead. Tin is a bit more reactive than lead. Now, if tin, so the question says, calculate the voltage where electrode A is lead and B is tin. So we just said tin is more reactive than lead. And if tin is B and B is more reactive than A, that means the final answer is going to be positive. So we are going to get, so let's quickly write this down. We know that tin is more reactive than lead. We said that electrode A is going to be lead and electrode B is going to be tin. So if B is more than A, according to this, if B is more reactive than A, that means the answer should be plus. So we know we're getting a positive voltage. But what about the value? So the value is just literally the difference between these two tables, because that difference is a difference between lead and tin. So if you do 0.5 take away 0.35, that will give you 0.15. So the final answer is plus 0.15. Okay, now batteries can be chargeable or rechargeable. If a battery is rechargeable, that means that there's a reversible reaction going on. So when you put it back into this charger, the reaction will reverse. Once you take it out, it will go one way. And once you put it in, it will go the other way. Okay, this is not an electrochemical cell. This is a fuel cell. This is known as the hydrogen fuel cell. So the way it works is that hydrogen comes in, and once it touches this electrode, it breaks down in this manner. So hydrogen breaks down into hydrogen ions plus electrons. Now, the hydrogen ions travel across through this electrolyte. The electrons go up into this machine, and for example, there might be a bulb here or a machine or a motor. So the energy is used to turn that or to turn it on, and then they keep going on downwards. Now at this electrode, oxygen comes in, the electrons come in, and hydrogen ions come in. So three things come together. So oxygen plus hydrogen ions plus electrons to make water, and water escapes. And this keeps on happening. And fuel cells will never stop unless you stop giving the fuel. Now, they might also ask you, where does hydrogen come from? So hydrogen is obtained from methane. Methane is an example of natural gas. Okay, so that's where hydrogen comes from. Also, they might ask you if this is an acidic or an alkaline fuel cell. Because you have hydrogen ions, you know it's acidic. If you had hydroxide ions, then it would have been an alkaline fuel cell. Again, here are the main equations. So you have the equation at the hydrogen electrode, the equation at the oxygen electrode, and this is the overall. And the way you get that is by adding these two together. So you got 4 electrons here, you have 2 electrons here. So first of all, let's double all of that. So I'm going to times it by 2. So 4 electrons plus 4 hydrogen ions, and that gives you 2H2. So now we can take this equation and this equation and then cancel out what appears on both sides. So for example, this and this cancel, the 4 electrons and this cancel, so that leaves you with 2 hydrogens and an oxygen, making 2 waters, and that's the final. So if they ask you to write the overall equation, it's the bottom one. So again, that's the overall equation. So the benefits of fuel cell is that there's less pollution. They don't release any carbon dioxide, sulfur dioxide, and nitrogen oxide. These two can cause acid rain. This can cause global warming. The only thing they release is water, which is not toxic to the planet. The other problems is that batteries contain toxic metals. However, fuel cells do not contain those. And also batteries have a recharging limit, whereas fuel cells, you can keep on using it as long as you supply the fuel. The disadvantage, however, is that because you have to carry hydrogen, it's going to take a lot more space. Also, hydrogen gas is explosive. And finally, you still do use some energy to get hydrogen from the natural gas. So it's not completely environmentally friendly because some electricity is required to separate the hydrogen from natural gas.